Good morning. Okay, today we're covering 3.3, which is properties of slopes and of lines. So in 3.1, you looked at slope and rate of change. You figured out how to determine the slope of a line from a graph, and you connected the idea of rate of change to slope. And you also, in 3.1, generated a graph from a table of values which was generated from an equation. So you took an equation, you created a table of values, and then you graphed that table of values. And you were able to determine from the graph the slope of the line. And you also should have been able to figure out the slope from the table. All right, that was 3.1. 3.2, yesterday, you looked at the equation of a line and how to determine the slope and the y-intercept from the equation of a line. And you were also able then to look at a graph of a line and determine the equation of the line by determining the slope and the y-intercept. And so today we're just going to talk a little bit more about slopes. So if you haven't done it already, please do the minds on for 3.3 and pause the video now. Okay. So today we are going to look at positive, negative slopes as well as slopes that are zero. And we're going to look at lines and decide whether they are parallel or not, judging by their equation from their table of values or from the graph. All right, so let's get started. You should have your note at the ready. So write the equation of a line with each of the following properties. So it's a slope of -3 and a y-intercept of 5. So we'll start as usual with y equals mx plus b and then just fill in appropriately. So we know that m is the slope, so we're going to have y equals -3 times x, and then the y-intercept is 5, so we're going to go plus 5. If the slope is 0 in this case, so we're still going to write y equals mx plus b, this is where you would get y equals 0x plus 6. We know that this term kind of disappears because we're multiplying x by 0, and whenever we multiply anything by 0, it is 0. So this is, of course, 0 plus 6, which just simplifies down to y equals 6. So I would expect you to give me the answer y equals 6. You don't have to show all these steps if you don't want to, but this is the final answer that I'm looking for, y equals 6. Okay, and if we have a slope of 5 and a y-intercept of 0, again, we're going to put the slope in where the m is in y equals mx plus b. So we're going to have y equals 5x. And then we don't need to write plus 0. So we're just left with y equals 5x. Hopefully you got all those right. All right, let's move on to the lesson. So remember that slope is y equals mx plus slope. The equation of a line, is y equals mx plus b, where m is the slope and b is the y-intercept. And we also remember that slope is represented by the letter m, and it is rise over run on a graph. So if I'm thinking about a positive slope on my graph, it's always going to look like this, where it's rising to the right. And so if you think about it, if I just drew in the x and y axis, so this is the x, this is the y, then we can think about it as we're moving to the right on our x-axis. So as our x's are getting bigger, what's happening to our y's? As our x's get bigger, our y's get bigger. So this is increasing, so it's a positive slope. Okay? If we have a negative slope like this one, then what's happening as we move along the x-axis is our y's are getting smaller. So our y's are going down. So this is a negative slope when the y's are getting smaller as the x's get bigger. And then the other two, just let me undo this if I can. The other two examples here, we've got a slope of 0. That's a completely horizontal line or a flat line. And then the other special case is where we have a completely vertical line, and that would be an undefined slope. All right, so let's look at some examples here. So it's asking, state whether the slope of each line is negative, positive, or 0. Well, the number in front of the x here is invisible, but it's a 1, not a 0. So the slope is 1, and the slope then is positive. So I'll just write slope is positive because there's a positive 1. Positive sign in front of the 1 just implied, right? We don't write the plus. So y equals negative 2x plus 1. Well, obviously the slope is negative 2, and that means the slope is negative because there's a negative number for the slope. Okay, y equals 1/4 x minus 0.1. Well, the slope is 1/4, and again, just because it's a fraction, it doesn't mean it's negative, right? The slope is still positive because it's positive 1/4. And last but not least, this one's tricky. This is not a slope of 0.5 because there would have been an x beside the 0.5. This number here represents the b. So the slope, the y-intercept, is 0.5, but the slope is what? If you don't see it, if you don't see an x term, it's disappeared, and it means the slope is actually 0. So this means the slope is 0. Okay, let's keep going. So for the graph here, for each line, we're going to decide which equation fits better. Well, let's look at the first one, y equals negative 4/3 x plus 4. I can see that my slope is negative 4/3. So I know that my slope here is negative. Well, let's look at our graph. Well, I've got this line here is rising to the right as my x's go this way, my y's go this way. So I can see that this one is a positive slope. So that's not the equation. This one is a negative slope. It's going the opposite way of this one. And this one as well is a slope that's negative. So it's one of these two. And so I'm going to look then at the b, the y-intercept. B is 4, and I know that my line then, this line, will cross the y-axis at 4. So this must be the line. So I'll just put like an A here, okay, for that one. So let's look at the next one. Y equals negative 2x minus 5. Again, the slope is negative. It's negative 2. And our y-intercept is negative 5, so I can see that this is the other negative line. So by default, that must be our answer. Let's just verify that the y-intercept is at negative 5. Yes, so this line is my b. And y equals x. Over here, my slope is 1. The number in front of the x is 1. And I know that my b is 0 because there's no number here. So my slope was 1, my y-intercept is 0. That's where it's crossing. The line is crossing where y equals 0. This must be C. It's got a positive slope. Okay, so that's not too difficult, right? All right, let's keep on going here. Parallel lines. So parallel lines have the same slope. So when we look at this one, this is the slope of 2. And this is a slope of 2. Is it the same line? No, because this line crosses the y-axis at 3, and this line crosses the y-axis at negative 5. So if they have the same slope, and they have different y-intercepts, let's just say this is our, oopsie, that doesn't look like such a great x and y-axis, but let's just say that's my x-axis, y-axis, that's my x-axis. You can see they have different y-intercepts here, but they're the same slope. They are the same steepness. They must then be parallel, and we indicate parallel with the little chevrons. Okay, so state whether the lines in each pair are parallel. Well, the slope of this one is 1/3, and the slope of this one is negative 1/3. So these are not parallel. They must be exactly the same slope. So just right up here, not parallel. It's a little bit tricky because the value is the same, but the signs aren't the same. This one's even easier because you can see the slope of this one is 5, the slope of this one is 2. These are not parallel. The number in front of the x in this case is 1. The number in front of this x is 1. Just going to verify that the y-intercepts are different, and they are, so these lines are parallel. This one, x has a coefficient of 1, a number in front of it is 1, and the number in front of this one is -1. So again, not parallel. They must be exactly the same. Okay, so now it's saying write an equation of a line that is parallel to each of these. Well, let's identify the slope first. So the slope of this one is 1. So I can write any other equation that has the same slope, so just an x with a 1 in front, as long as the y-intercept is different. So for y equals 0, if we wanted to write an equation that is parallel to y equals 0, we know that y equals 0 is a line that has a slope of 0 because there's no x term. And so we could write any equation that has no x term and another y-intercept, a number different than this one. So it could be any other number other than 0. So y equals 2 is a good example. It could have been y equals -5, etc. Now this one, C, is quite tricky because this is not in slope y-intercept form. Slope y-intercept form has to be x term first and then the number. So if I'm changing this into y equals mx plus b form, I'm going to put the negative x, I take the sign with me when I move the x in front of the 8. And the sign in front of the 8 right now is a positive sign. You don't see it, but it's invisible. So there, now we've got it in slope y-intercept form. So the slope of this is actually -1, and the y-intercept is 8. So if I want to write an equation of a line that is parallel to this line, remember it has to have the same slope. So our answer might be something like y equals -x, that's the same slope, but a different y-intercept, so we could say -3. Okay, these are just examples. So, for example, I could have that. For example, I could have that. It's not the final only answer, right? There are many different ways you could have answered this as long as this part is the same as this part. All right, let's do the last example. I believe it's the last example. It says, determine whether the lines represented by each pair of tables of values are parallel. So, is this line that's represented here parallel to this one? Well, I'm lazy. I do not want to graph this set of points, each set of points, and check to see if they look parallel. What I want to do is figure out the slope. So remember, slope is the same as the rate of change. And so all I have to do is take the second y minus the first y, the third minus the second, the fourth minus the third. And because my x's are going up by 1, I know that whatever those numbers are is the slope. So -2 minus -3 is +1. -1 minus -2, +1. 0 minus -1, +1. So for this particular one, I'll write it over here, the slope is 1. Let's check the next one. -1 minus 0, that's -1. -2 minus -1, that's -1. -3 minus -2, again -1. Well, then the slope is -1. Are these lines parallel then? If they have the same slope, yes. If the numbers are different, no. So I would say, therefore, the slopes are different. So the lines are not parallel. All right, let's try the next one. So we've got, oh, yikes. Sorry about that. Let's go back. We've got numbers going up by ones again. And this time 5 minus 5, well, that's pretty easy. That's 0. 5 minus 5 again, 0. So we've got a slope of 0. And that's possible, right? That just means it's a horizontal line. What about this one? Negative 1 minus minus 1. Well, negative 1 minus minus 1 is negative 1 plus 1, which is 0. Just do it on your calculator if you don't trust me. 0, 0. Well, the slope here is 0. The slope here is 0. And these are two horizontal lines. So the slopes are the same. So the lines, so the linears, is that what I wrote up there? So the lines are parallel. I don't know what I was thinking. So the lines, I put linears for some reason. There we go. All right. So that's the lesson. So right now what I would like you to do is do your consolidate for, what is it, chapter 3.3 in your AFL booklet, and get started on your textbook work, please. So I do not know what those numbers are, so you're going to do the consolidate for 3.3. You're going to do your homework, classwork, and that's going to be in your, so do the classwork for 3.3 in your unit outline. And we are going to have a quiz tomorrow on 3.1 to 3.3. And when I say tomorrow, I mean Friday, because you have literacy test tomorrow. Okay, so good luck, everybody. Please ask me any questions that you have.